Okay, triangle of vector addition we were discussing yesterday. So here two vectors are given. Two vectors are given, vector A and vector B. And how will you add them using triangle law of vectors? That is what we have to study. And statement also you should know. So what is given? Two vectors, vector A and vector B. And we have to find out whether these vectors can be taken as the sides of a triangle. So we are checking that. First we represented vector A with the same magnitude and same direction. Magnitude, suppose this is 3 centimeter, we have to represent it with 3 centimeter. And same magnitude, same direction. Like that we have represented. And then at its tip we keep this vector B with the same magnitude and same direction. So you have to draw it parallel here. It is possible. Now we check, when we check it, we find it is possible to represent vector A and vector B as the sides of a triangle in the same order. So sides of the triangle, this blue line, that is the B vector. So now what we have done, we have represented vector A and vector B as the sides of a triangle in the same order. Order is very important. When we keep it, we should keep it in the same order. Don't keep a vector B here. Don't keep it here. At its tip you have to keep in the same order. Like that you have kept. Now vector A is kept with the same magnitude and same direction as one side of the triangle, and vector B is kept at its tip and it is the second side of the triangle, and they are in the same order. Don't put arrow mark here. When you keep the vector B here, don't put the arrow marked part here. That should be away from it. That means its tail only should meet here. Tail of vector B is kept at tip of vector A. Like that you have to keep. And what more things we have to see? Whether they are in the same direction, whether they are having the same magnitude, that you have to check. Now vector A and vector B are the two sides of a triangle taken in the same order. Then third side of the triangle in the opposite order will represent the resultant of those two vectors. So third side of the triangle you just join. Third side of the triangle is joined, and order you have to take opposite order. So if it is in the same order, tail, tip, again tail, tip, it should come here. Arrow mark will be here if it is in the same order. But it is not like that. You should not take the resultant in the same order. Resultant is always in the opposite order. So arrow mark will be here. Arrow mark will be here, opposite order. So now we got the resultant of these two vectors, A and B. What is the resultant? Resultant is this vector, red line, no? Red line, that is the resultant. Joining tail of this vector or to the tip of this vector. Or it is the third side of the triangle taken in the reverse order. So this is just like a tail to tip method, same method. But here we have represented them as the two sides of the triangle in the same order. Then resultant is the third side of the triangle in the reverse order, like that. So what we have seen here, we have used triangle law of vector addition. If vector A and vector B can be represented as the two sides of a triangle in the same order, then third side of the triangle in the reverse order or opposite order will give the magnitude and direction of the resultant. So statement I will show you. Statement, what all things you have to be careful. The triangle law of vectors states that if two vectors acting on a particle at the same time are represented in magnitude and direction by, this is the important thing, magnitude and direction by the two sides of a triangle taken in same order, that is important, same order, their resultant is represented in magnitude and direction. Oh, see, here this is important. Resultant is represented in magnitude and direction by the third side of the triangle taken in opposite order. So that is the statement. So all of you have to study the statement. All of you have to draw the figure like this. And B plus A also you can do. First you draw the vector B with the same magnitude, same direction. Then you draw vector A in the same order as the second side of the triangle. So this is the first B vector is taken as the first side of the triangle. Then A vector is taken as the second side of the triangle. They are in same order. Arrow mark you see? They are in same order. Then how will you find the resultant? Now we have represented the two vectors as the two sides of the triangle in the same order with the same magnitude, same depth. Then how will you find the resultant? Third side of the triangle. This is the third side of the triangle. Joining the third side we get. And order, reverse order. Third side of the triangle in reverse order will represent the resultant of those two vectors. That will give both magnitude and direction of the resultant vector. Not only the magnitude, it also gives the direction of the resultant vector. So, and we also can show that A plus B equal to B plus A. You see that red colored line, that is our resultant. And A plus B is added, A and B are added, this is the result. And here B and A are added, this is the resultant. They are parallel, and you know, if you take the same scale, then their lengths also will be equal. Direction is same and magnitude also will be same. So A plus B equal to B plus A, that we have already seen in geographical method of addition also. Yes. Okay, wait.
Can you help me add it?
Okay. Next is parallelogram law of vectors. So triangle law we have studied now. Next is parallelogram law of vectors. I will show you the other figure. Parallelogram law of vectors. Here, if two vectors can be, suppose there are two vectors, vector A and vector B, and if they can be represented as the sides of a parallelogram. Earlier was sides of a triangle. This case is if two vectors can be represented as the two sides of a adjacent sides of a parallelogram. If two vectors given vectors, vector A and vector B, can be represented as two adjacent sides of a parallelogram, then how will you find the resultant? You just complete the parallelogram. Then diagonal starting from the meeting point of these two vectors, starting from the joining point of these two vectors, that will give the resultant. So vector OS, that will give the resultant of these two vectors. So either you can use triangle law of vector addition, or you can use parallelogram law of vector addition if two vectors are given. First, what you have to check, whether it is possible to represent them as the sides of a triangle in the same order. Or if it is not possible to represent them as the sides of a triangle, then you try whether it is possible to represent them as the sides of a parallelogram, adjacent sides of a parallelogram. Then you just draw vector A with same magnitude, same direction, and vector B with same magnitude and same direction from the same point they are drawn. They are represented as the adjacent side of a parallelogram. Okay, your first work is that. we have represented them as the two adjacent sides of a parallelogram. Then you just complete dotted lines I have used to complete the parallelogram. Then draw the diagonal. We know there are two diagonals. One is joining Q to P, we get one diagonal. Q to P, when we join, we get one diagonal, and other diagonal is joining O to S. Which diagonal represent the resultant? The diagonal starting from this point of intersection of the given two vectors. Given two vectors are A and B. A and B are the given two vectors. Their joining point is O. From there, you have to draw the diagonal. That diagonal will represent the magnitude and direction of the resultant vector. What is resultant vector? Sum of these two vectors. Resultant vector is the sum of these two vectors. So this is the parallelogram law of vector addition, and we will show you a statement. Statement. See, this is the statement. Parallelogram law of vectors states that if two vectors acting on a particle at the same time are represented in magnitude and direction by the two adjacent sides of a parallelogram drawn from a point, then the resultant vector is represented in magnitude and direction by the diagonal of the parallelogram drawn from the same point. Drawn from the same point. Okay, so that is the statement. And you know, there is a derivation also that we have to study, but that derivation I will take after stating this polygon law of vectors. Polygon law of vectors. I will state that. Polygon law of vectors. So the two statements we have studied, triangle law of vector addition and parallelogram law of vector addition for adding two vectors. And here, if a number of vectors are there, not two vectors, number of vectors are there, for example, vector A, vector B, vector C, vector D, like that number of vectors are there, then how will you find the resultant? For that we use polygon law of vectors. Polygon means many-sided figure, like polygon. So first, given vectors, you have to check whether it is possible to represent them as the sides of a polygon. See, here vector A, vector B, vector C, vector D are given, different direction, different magnitude are given. First, what we have to do, represent vector A. Near to that vectors, you take a point O, and from the point O, you draw vector A with the same magnitude, same direction. I have drawn it here. OP. Vector A, vector OP is vector A. Same magnitude I have taken, that means measured with a scale and drawn. Same direction also I have noted. So you also have to do like that. Same magnitude, same direction. I have represented vector A here. Next, you have to check whether the vector B can be represented as the other side of the polygon. So when you do it, you have to find out magnitude and you have to find out the direction also. So represent B at its tip. Tail of vector B is kept at its tip. Because they are in the same order, they must be in the same order. So that is possible one, tail tip, like that if it is kept, it is possible. So tail of vector B is kept at P, and we have to see whether this vector B and the vector B we are representing here, both are having same magnitude and same direction. Okay, that also represented. Vector PQ represent vector B. Then third vector. Okay, we can move forward to the third vector, vector C. And you at the tail of vector C is kept at tip of vector B, and also obey that the magnitude and see that magnitude and direction are same as that of this C. Magnitude and direction are same as that of the given vector C. Suppose this is 5 centimeter, you have to represent here 5 centimeter, and the direction there should be parallel. This vector C and this vector C, they must be parallel. So we have represented C also with the same magnitude, same direction, and in the same order. Now one more vector is there, that is vector D, and tail of vector D is kept at tip of vector C, and also find whether the magnitude and direction are same. When you keep it at its tip, you have to see whether the magnitude and direction are same. So now vector D also represented with same magnitude and same direction. Then how will you find the resultant? Now all vectors we have represented. Now how will you find the resultant? Very easy. You just join the beginning point and the end point. Just join that and put the arrow mark in the reverse order. Put the arrow mark in the reverse order, not in the same order. The line joining the beginning point and the end point in the direction in the reverse order. Last side of the polygon in the reverse order will represent the magnitude and direction of the resultant vector. Last side, closing side of the polygon in the reverse order will represent the magnitude and direction of the resultant vector. So that is the polygon law of vector. So I will show you the statement again. It states that if any number of vectors acting on a particle at the same time are represented in magnitude and direction by the various sides of an open polygon taken in the same order, their resultant is represented in magnitude and direction by the closing side of the polygon taken in opposite order. So all the statements study well, and everyone should know how to state and draw this figure. Okay. Statement study, figure also. Okay, next derivation is there. Using the parallelogram law of vector division. How will you find the resultant? Now the only diagram drawing only we have studied. How to find the resultant using the parallelogram law. That we have to study. It is a very important question. Usually that asks as a 5-mark question and all. When descriptive questions asked as a 5-mark question. So find the question I will show you. Yes, this is the question. Find the magnitude and direction of the resultant of two vectors, vector A and vector B, in terms of their magnitudes and angle theta between them. What's the question? Find the magnitude and direction of the resultant of two vectors, vector A and vector B, in terms of their magnitudes and angle theta between them. So we are given two vectors, vector A and vector B, and we have to find out the resultant of those two vectors, and you have to find out the magnitude and direction in terms of that angle, that means magnitude and direction. You have to find out both magnitude and direction, you have to find out. Okay, let us see the derivation. Yes, you see, we are going to find the resultant. So first we have represented vector A and vector B as the two sides of adjacent sides of a parallelogram. Then to find the resultant, you just complete the parallelogram, dotted lines, using the dotted lines, complete the parallelogram. So this will be parallel to this. A, vector B that will be parallel to this side, vector B. Now we have completed the parallelogram. Then draw the diagonal from the same point where we have represented vector A and vector B. Vector A and vector B we have represented from the point O. So from there you draw the diagonal red color line. That is the resultant of vector A and vector B. So in figure you can say vector R equal to vector A plus vector B, but that is not enough. Vector R equal to vector A plus vector B, that is not enough. That is statement, you can tell that. But you have to find out the magnitude. Magnitude equation is there, derivation is there, find the magnitude. Okay, so for finding its magnitude, what we do is we extend this line to use Pythagoras theorem. We are making it a right angle triangle. So what we have to do is extend OP, extend it, and from S you draw a perpendicular. Extend OP and draw a perpendicular. So this becomes a right angle triangle now. Which one? OSN. OSN becomes a right angle triangle now. Now OS square equal to Pythagoras theorem. OS square equal to ON square plus SN square. Pythagoras theorem. OS square equal to ON square plus SN square. Okay, that is written. OS square equal to ON square plus SN square. And then SN, what is SN? SN, okay, SN, no change, SN square. What is ON? ON is the sum of these two, OP plus PN. PN we don't know, OP we know, that is magnitude is A. But PN we don't know. How will you find PN? There is a method. If this angle between A and B is theta, this angle also will be theta. Angle between A and B. This is a vector A extended and this is vector B. So this angle also will be theta. Then we have to find out SN. SN for finding SN, we find sin theta. For finding PN, we find cos theta. Okay, so let us see that step. So cos theta equal to adjacent side by hypotenuse. Adjacent side is PN, by hypotenuse is this triangle, small triangle. Here, which is SPN triangle. Triangle SPN, cos theta equal to PN by B. Therefore, PN equal to B cos theta. And sin theta equal to sin theta, opposite side by hypotenuse. Opposite SN by B. SN by B. So SN equal to B sin theta. So cos theta we got and we found PN. PN is the adjacent side, PN of this triangle. PN equal to B cos theta and SN equal to B sin theta. We got PN and SN. When we can substitute that in that equation, in the equation we got, we can substitute PON equal to OP plus PN. So OP is A, magnitude of OP is A. And PN just now we have calculated B cos theta. So that is substituted here, A plus B cos theta. And SN also we got B sin theta. So next step we are substituting that OS square equal to ON square. What is ON? A plus B cos theta whole square plus what is SN? SN is B sin theta. So B sin theta whole square. Okay. Next we are squaring A plus B whole square. That formula is used. A plus B whole square. A square plus 2AB plus B square. That formula is used. A square plus 2AB cos theta plus B square cos square theta. Oh, this term is not there. This term is not there. A square plus 2AB cos theta plus B square cos square theta plus B square sin this term square. B square sin square theta. Children, this term is not there. That I will cut and send. When I send the copy, this term is not there. A square by mistake I will. A square plus 2AB cos theta plus B square cos square theta plus B square sin square theta. And we know B square cos square theta plus B square sin square theta is B square into cos square theta plus sin square theta. that is b square into 1. So we get a square plus b square plus 2ab cos theta. So r square equal to a square plus b square into cos square theta plus sin square theta plus 2ab cos theta. A square plus b square, this becomes 1. Cos square theta plus sin square theta becomes equal to 1. So we get b square plus 2ab cos theta. R is either for r equal to that, r is the resultant. R square is this. Therefore, r equal to square root of a square plus b square plus 2ab cos theta. Very important formula. This is also known as law of cosine. Cos term is there. So it is known as law of cosine. What is law of cosine? R equal to resultant, r equal to root of a square plus b square plus 2ab cos theta. What is a and b? A and b are their magnitudes. What is theta? Theta is the angle between a and b. Okay. So now we got one resultant. We got resultant. Then direction, to find direction, different methods are there. Direction. So resultant is a vector quantity. We need both magnitude and direction. This gives only the magnitude, r equal to root of a square plus b square plus 2ab cos theta. That gives the magnitude of the resultant. Direction we can find out by different methods. One different method I will explain. So for that, you see this figure. So this angle is taken as alpha, direction of the resultant. That means how much it is inclined with this x-axis. That means vector A. That is marked as alpha. Inclination of this vector R with A. Alpha it is marked. And this angle we can express with this angle also with vector B. What is the direction? That is vector R, beta. Beta. Vector B is making an angle beta with the result. And so alpha and beta are marked in that figure. Then you can find the direction in terms of alpha or beta. So for that, you can take another triangle, pair of triangle OSN. OSN, where is that? Here, OSN triangle. SN equal to OS sin alpha, OS sin alpha. You can see the steps here. Sn equal to Sn by OS is sin alpha. Therefore, Sn equal to OS sin alpha. OS is the resultant R sin alpha. Similarly, triangle PSN, take P small triangle PSN. In triangle PSN, Sn equal to PS sin alpha. Sn by PS is equal to Sn by PS equal to sin alpha, opposite side by hypotenuse. Sn by PS equal to sin theta, sorry, not theta. This is theta. Sn by PS equal to sin theta, or Sn equal to PS. That's equal to B sin theta. B sin theta. So therefore R sin alpha equal to B sin theta. Why? Both are Sn. Sn equal to R sin alpha. Sn equal to B sin theta. So we can equate them. R sin alpha equal to B sin theta. R sin alpha equal to B sin theta. Therefore, R by sin theta equal to B by sin alpha. Cross multiplying, we get this R sin alpha equal to B sin theta. R by sin theta equal to B by sin alpha. One equation we got to find the direction. And one more equation is there. From triangle, you have drawn a perpendicular here. We have drawn a perpendicular here. PM. This is the opposite side of this. So, what is PM? From this beta, in terms of beta, you are finding. So, a triangle PSM, take PSM triangle. PM by A. What is PM? PM by A. PM by A. What is PM by A? PM opposite side. This adjacent side. Okay. Pm by A equal to, Pm is opposite side, sin alpha. Pm by A equal to sin alpha, Pm equal to A sin alpha. And which is also equal to, in terms of beta, it is sin beta. Pn by B equal to sin beta. So that is also equal to B sin beta. Everyone, after going home, you have to derive all these expressions 2 or 3 times, write and study all the derivation, how to write the magnitude and direction. Okay. So first, Pm is found from this triangle, VOMP. This triangle we find Pm. From another triangle SMP, we find Pm. Using this triangle also we find Pm, and both are equated. So using this triangle, Pm equal to A sin alpha, and using this triangle, Pm equal to B sin beta. So they are, both are Pm. So we can equate them. So A by sin beta equal to B by sin alpha. So you see equation 2 and 3. Look equation 2 and 3. R by sin theta equal to B by sin alpha. Here also one B by sin alpha is there. So that is equal to A by sin beta. So what we can compare and write? R by sin theta equal to B by sin alpha equal to A by sin beta. So this is also used to find the direction of the resultant vector, either in terms of alpha, either in terms of beta, or in terms of theta. We can find out the direction. When you do problems, you can make it clear, more clear. So first you derive the equation. Just write and study the derivation part. Then next law, sine law is the law of sine to find the direction. Usually we use this direction, this one. So if magnitude direction is asked as a question, you can write this. If you find this part difficult, you can use this part. That means sine law. That is the easier part. But in certain situations, we have to use this law also. That's the problem. So we can use this equation. Yes. Direction of the resultant is also given by tan alpha. Tan alpha, you see bigger triangle, you can take bigger triangle O, S, and that triangle you take, then tan alpha, opposite side Sn by adjacent side On, Sn by On, but On is OP plus Pn. On is OP plus Pn. So substitute that Sn by OP plus Pn, and Sn we already got in terms of theta, it is B sin theta. Sn equal to B sin theta, and OP is magnitude of vector A, and Pn is B cos theta. In terms of theta, we are writing B sin theta plus A plus B cos theta. Okay. So tan alpha is equal to B sin theta by A plus B cos theta. Theta, what is theta? Theta is the angle between A and B. Theta is the angle between A and B. So theta, suppose they are making an angle 45 degree, you can substitute that theta in the place of theta 45 you can give, and you will get the answer. So you can find out the direction alpha. So this is the method used to find the magnitude and direction of the resultant by using parallelogram law of vector addition. So what all things you have to study here, make it clear. So first question I will show you again. Very important. Very important. This is the question. Find the magnitude and direction of the resultant. But both we have to find out. Magnitude and direction. Both we have to find out. Of what? Two vectors. Vector A and vector B. In terms of what? In terms of magnitude. and angle theta between them. So in terms of angle theta between them, you have to find out magnitude and direction. That's why last result we have expressed in terms of theta. Only 5 minutes more. Only you are able to take parallelogram on with the question. That's the statement. Also we have studied triangle law of extradition, parallelogram law of extradition, and polygon law of extradition we have studied today, and also the derivation question. What is the magnitude and direction of the resultant when we use parallelogram law of vector addition? So first what we have done, we have expressed them as the sides of a parallelogram. Then completed the parallelogram. Then what is done? Draw the diagonal passing from the same point. That will give the resultant. Then what is done? To apply Pythagoras theorem. To find OS, what we have done? We extended this line and drawn the perpendicular. Then OS square equal to ON square plus SN square. Then ON is equal to OP plus PN. What is OP? OP's magnitude is A. What is PN? PN in terms of theta, PN is B cos theta. SN is B sin theta. So we have substituted that. Substituted A plus B cos theta whole square plus B sin theta whole square. And like that we calculate. So R, what is the magnitude we got? Magnitude R equal to root of S square plus B square plus 2AB cos theta. Magnitude. And direction, best study this. This is also known as sine law. All signs are used. This is known as cosine law. Cosine law. This is cos is cosine law. This is known as sine law. And direction can also be expressed in terms of theta. Actually, question is like that. Direction you have to express in terms of theta. So tan alpha is determined, and you can find out alpha with that. And there is you have to buy one table, Clark's table, to find this direction and all.